Students, your lecture of multivariable calculus is directional derivatives. As you have earlier studied partial derivatives for function depending on more than one variable, here is a function here which is depending on two variables x and y, so you can find out its partial derivative with x and y. Directional derivatives are those derivatives which gives you rate of change with the direction. If you're having a line segment of 5 centimeter, it means it only gives you the magnitude at a scalar, but if a direction is assigned with it, that line segment becomes a vector. Here you are having a question of a similar function and you have to find out its partial derivative, first order partial derivative with x and y. These partial derivative only gives you the magnitude. This means that the partial derivatives, they are only scalars. So how can you write the partial derivatives in a manner that they give you the direction as well? And the answer is gradient of f. Gradient of f is equals to del f. Del f is written as this form, the notation of the brackets with partial derivatives separated with a comma. When you are using these notation, you do not write the vector I and j, but when these notations for the gradient of f in the mathematical form, they are not used, then you can write the vectors I and j with it. Now here you are having question number 1. Function is depending on three variables x, y, z. You have to find the gradient of f at the particular point. You find first order partial derivative with x, y, z. Now you will evaluate these partial derivatives at the specific point. So the first order partial derivative for x is 20, for y it is 14, and for z it is 8. These partial derivatives, they give you the scalar. So now you are going to write them in the form of gradient of f. Del f equals to the notation of bracket and three partial derivatives separated with commas. When the notation for the bracket is removed, then you can write I, j, and k vector. Now these are the partial derivatives which are giving you magnitude as well as direction. You are having two practice questions in which the function is depending on three variables and you are just supposed to find out the gradient of f at a specific point. So what are the directional derivatives in terms of a formula? The directional derivative is actually the dot product of the gradient of f with a unit vector u. Specifically, the unit vector is written with u, which means that if in a question the vector is given with u, it means it is already a unit vector. You do not have to find the unit vector. But if a vector is given with any other symbol like v, x, a, then you are supposed to find out the unit vector first. For example, I have considered a vector u. So this means this vector is already a unit vector. You will not find out its unit vector. But if a vector is given with v, 3 and minus 4, you have to find out its unit vector first. So what is the formula of finding out the unit vector? The vector divided by its magnitude gives you the unit vector. Vector is 3i minus 4j and its magnitude is square root 25, which is 5. So the unit vector for vector v is actually 3 by 5 and minus 4 by 5. So here is the formula for the directional derivative for a function. Dot product of gradient of f into unit vector u. Now in the question number 1, a function is given x square plus xy. Point is given 1, 2 in the direction of vector u. So the vector is already u, so it means it is a unit vector. Now the solution, function is given, point is given, unit vector is given. You will calculate the first order partial derivatives. In step 2, you will evaluate these partial derivatives at the specific point 1 and 2. You will get the particular answers for the first order partial derivatives. Now in step 3, you will express the partial derivatives in terms of gradient of f. You have expressed in gradient of f. Step 4 is to find out a unit vector, but here the unit vector is already given to you. Step 5, you will write down the formula. In step 6, you will do the dot product. 4 it will be multiplied with 1 upon square root 2. Positive sign, 1 will be multiplied with 1 upon square root 2. Take the LCM and the final answer is 5 upon square root 2, which is the directional derivative of the given function. Question number 2 is your practice question. Function is given, point is given in the direction of vector v. So this means you have to find out the unit vector for this question. And the answer is given. You can solve and you can check. Question number 3, a function is depending on three variables x, y, z. You have to find out its directional derivative. Point is given as 1, 3, 0 in the direction of vector v. So here the vector is v, means you are supposed to find out the unit vector u. Solution is that function is given at a specific point. Vector v is given. First we will find out its unit vector. Vector I plus 2j minus k over its magnitude. The magnitude is square root 6. So unit vector is I plus 2j minus k over square root 6, which is written with the bracket notation in equation number 1. So after finding out the unit vector, now we will find out the partial derivatives. Partial derivative with x is sine yz, partial derivative with y is x, cos yz, and for the angle we will get z. Partial derivative with z is x, cos yz, and the answer for angle is y. Now you will calculate these partial derivatives at a specific point. The answers will be 0, 0, and 3. Now you will write these partial derivatives in the form of gradient of f. So it is 0, 0, 3 in the notation. Now you will apply the formula gradient of f into the unit vector, gradient of f in the notation of the brackets, similarly the unit vector. Now you will dot product for each specific term, and the answer is minus 3 by square root 6. So your answer for the directional derivative for the given function is minus 3 upon square root 6. Practice question in 11th edition, they are mentioned question 1 to 16 for the directional derivatives. The second subtopic is the maximum and minimum value of the directional derivative. Now to find out the maximum value, at which point you can have the maximum value for the directional derivative. This is the formula for the directional derivative. It's the dot product. So how do you open the dot product of two vectors? Magnitude of first vector, magnitude of second vector into cos theta. So my two vectors are gradient of f and unit vector. Magnitude of gradient of f, magnitude of unit vector into cos theta. So what should be the angle between these two vectors so that cos is having the maximum value? It is 0. So if theta is 0, it means that your gradient of f and unit vector, they are in the same direction. As you know that unit vector is having magnitude 1. So what will this equation become? Magnitude of gradient of f into 1 cos of 0. Cos of 0 is 1. So the maximum value of directional derivative is the magnitude of gradient of f. It's the formula. Now in which direction do you get the maximum value of the directional derivative? Both vectors are in the same direction. So the direction is actually written with the vector u. The gradient and the unit vector, they are in the same direction. So the direction in which the directional derivative is maximum is vector u equals to gradient of f over its magnitude. So the formula for the direction in which the maximum value occurs. And what is the maximum value of the directional derivative? That is the magnitude of gradient of f. Similarly, for the minimum value of the directional derivative, again the dot product, the formula, the dot product is opened. What can be the minimum value of theta for these two vectors when they are in the opposite direction? Gradient of magnitude of gradient of f in one direction and magnitude of unit vector is in the other direction, so that you are having an angle of 180 degree and cos 180 is minus 1. So what will you have? Magnitude of gradient of f, magnitude of unit vector is 1, so you'll have 1 over here, cos theta as it is. Minimum value will exist when both these vectors are in opposite direction. Theta will be 180, so cos 180 will be minus 1. So what is the formula of the minimum value of directional derivative? That is negative sign outside and magnitude of gradient of f. And the direction now in which this minimum value occurs is given by the vector u, negative sign, gradient of f over its magnitude. This is the formula when the directional derivative is having the minimum value. Now we will apply these formulas in a question. Find the maximum and minimum value of the directional derivative of this function at point given. Function is depending on two variables. First, we are going to find the maximum value of the directional derivative. So this is the formula. Maximum value of directional derivative is magnitude of gradient of f. And this u will come in the subscript, not along with d. First step is that find out the gradient of f. Here is the function depending on two variables. First, you will find out the first order partial derivative with x, then with y. In the next step, you will evaluate these partial derivatives at point 2 and 0. The answer is 1 and 2. You will write these partial derivatives in gradient of f, which are written. Now you will take its magnitude. The answer is square root 5. So now you will apply the formula that directional derivative is maximum. That is actually the magnitude of gradient of f. And the magnitude of gradient of f is square root 5. The direction in which it occurs, u equals to gradient of f over its magnitude. Gradient of f is 1, 2 in the notations divided by the magnitude, that is square root 5. So the direction in which it occurs, here it is written in with I and j vector. Second part is to find out the minimum value of the directional derivative. The point where the minimum value of the directional derivative occurs is given as negative of the magnitude of gradient of f. As you have already calculated the magnitude of gradient of f as square root 5 here. So here it will only be replaced with the negative sign. Now the direction in which this minimum value occurs, vector u equals to negative sign gradient of f over the magnitude of gradient of f. What was the gradient of f? 1 and 2, and magnitude was square root 5. Now when you remove these notations, you can write the vector I and j. Now you can have the practice questions to find out the maximum and minimum value of function depending on 3 variables at a specific point. When you're finding the minimum and maximum value of directional derivative, there is no need of a vector. That's why vector is not given over here. The answer is given, and the practice questions for the maximum and minimum value of the directional derivative, they are in exercise 14.5 from question 17 to 22.